We shall now discuss tangent lines and derivatives. In geometry, a line that intersects a circle in 2 points is called a secant line, and a line that intersects a circle at exactly 1 point is called a tangent line. Now let's consider the secant line and the tangent line in this figure here. Point P and point Q are on the secant line, and point P is on the tangent line. Now notice that if I move Q closer to P, my new secant line will be this line here. And then if I move closer to P, the secant line becomes this. Notice that if I even move even closer to P, the angle between the secant line and the tangent line gets increasingly small. It will decrease to the point that the two lines becomes really close to each other. And so therefore, based on that illustration, we see that as we move Q really close to P, we can then use the slope of the secant line to approximate or to find the slope of the tangent line. Now let's take a look at this illustration here. Suppose one point is at x equals a. The point that corresponds to that will be the point A, f of a. And if the other point is h distance away from A, that next point will have an x value of A plus h. And that will correspond to this point here, which has the ordered pair A plus h, f of A plus h. Now, if you connect these 2 points here, you have a secant line. Now, to obtain the slope of the secant line here, you just compute the change in y divided by the change in x. So you look at the y coordinates for the 2 points, and then you subtract the y coordinates to get the change in y. So you have f of a plus h minus f of a, divided by the change in the x coordinates. So to obtain that, you just subtract a plus h minus a. And a plus h minus a is just equal to h. Notice that our first point has x coordinate of a, and the second point has the x coordinate of a plus h. So a plus h is actually h distance away from a. And that's what you will get when you subtract the two x coordinates here. From here, we say that the slope of the secant line in general is equal to f of a plus h minus f of a over h, where the first point is at x equals a, and the second point, it has an x coordinate or is h distance away from a. Now notice that if I move this point here closer to A, so if I go from there, I'll move it here. This will be my new point, and that new h distance from A to the second point is actually a lot smaller than the original h. And now if I move that even closer to this point here, the new distance from A to the next point, to the second point, is even smaller than the previous one. And if you continue that process, as you move it really, really close to A, this h here will approach to 0. And so in that case, as h goes closer to 0, the second point becomes very close to this original point here. And that secant line would eventually intersect the tangent line at this point. So in other words, if you take the limit of the slope of the secant line as h approaches 0, this value will approach the slope of the tangent line at that point. With that, we say that the slope of the graph at the point A, f of A, which is given by the limit of the slope of the secant line as h approaches 0, is the slope of the tangent line to the graph through the point A, f of A. Now, in general, we now define the derivative of the function at any x. So for a given function f of x, the derivative of the function at x is denoted by this symbol here, which can be read as f prime of x. And this is given by this formula here. This formula here is just the slope of the secant line from point x to any point x plus h. So the second point is h distance away from x. And you take the limit of that slope of the secant line as h approaches 0. And if the limit exists here, then we say that the derivative of the function at x exists. And moreover, if the derivative of the function exists for any x in a given open interval ab, then we say that f is differentiable over the open interval ab. Now, in summary, we have to take note the following. The derivative of a function f is a new function, and we call that f prime. And the domain of the derivative is a subset of the domain of the function. And the derivative has various applications and interpretation, including the slope of the tangent line. This means that for x in the domain of the derivative of f at any x is the slope of the tangent line to the graph of f at the point x f of x. And we also interpret derivative as the instantaneous rate of change. So the derivative is the instantaneous rate of change of the function with respect to x. And lastly, we interpret it as the velocity. So if your function is said to be a position function of a moving object at time x, then its derivative is interpreted as the velocity of the object at that time. So to get the derivative of a function f of x, we follow this four-step process. First, we find f of x plus h. That means you substitute x in f of x by x plus h. And then second, you get the difference between the result here, the f of x plus h, and the function, the function given, f of x. Then next, you divide the result here by h. Then lastly, you take the limit of this expression here as h approaches 0. Use the four-step process to find the derivative of f at x for f of x equal to negative 10x squared plus 3x minus 7. So as a first step, we obtain f of x plus h. So that means you replace x here by x plus h. So you have negative 10 x plus h squared plus 3 times x plus h minus 7. Then you expand this using FOIL method or using the special product formula. So this is negative 10 times, so when you expand this, you have x squared plus 2xh plus h squared. And then you distribute 3 to each term inside the parentheses. So plus 3x plus 3h minus 7. And then distribute negative 10 to each term inside these parentheses. So you have negative 10x squared minus 20xh minus 10h squared plus 3x plus 3h minus 7. Then next you simplify. You combine similar terms if there's any. In this case, there's no similar term. So we'll go ahead and proceed to the next step, which is f of x plus h minus f of x. So you just copy the result here and then subtract the expression for f of x. So you have negative 10x squared minus 20xh minus 10h squared plus 3x plus 3h minus 7, and subtract this by f of x. This is your f of x. So you have negative 10x squared plus 3x minus 7. Now subtracting these two, notice that this term here is also in here, and this one here is here, and negative 7 is also here. So that means that we can cancel this expression here. That cancels out because you subtract them. This one minus this will be 0, and negative 7 minus 7 will also be 0. And so subtracting these two will leave us with the expression negative 20xh minus 10h squared plus 3h. Then the third step is to divide the expression by h. F of x plus h minus f of x divided by h. And so you have negative 20xh minus 10h squared plus 3h divided by h. So h is a common factor in the numerator. So we have h times negative 20x minus 10h plus 3 divided by h. So h is a common factor. That means we can cancel h. So this cancels out. So therefore, this is equal to this. Now as a fourth step, we then take the limit as h approaches 0 of f of x plus h minus f of x divided by h. So we use this result here and take the limit as h approaches 0. So we have limit as h approaches 0 of negative 20x minus 10h plus 3. So as h approaches 0, this term here goes to 0. So therefore the limit here is equal to negative 20x plus 3. And so based on the definition, we say that the derivative of the function at any x is given by negative 20x plus 3.